Today we're going to complete Unit 3, Lesson 8. This will be the last lesson in this unit. And it is, of course, our applications, okay? So I'm going to move this over. I'd like for you to, before we get started, write down these notes on the top of your paper. The notes say, how do we choose which method? So we have now already learned and practiced substitution, elimination, and graphing methods. So we have 3 methods that we utilize. Today, what we're going to be doing is answering applications. So with an applications problem, we always need to do step 1 right here in this first box, which is to define our 2 variables. Define your variables first. Second, we will then translate the information provided into 2 equations. Third, we will solve this system. So remember, we've got method substitution, we've got elimination, and then of course we have our graphing method. Okay, so we are going to be using all 3 methods to solve our systems. And then finally, we're going to give a final answer to what the problem is asking. All right, so substitution method, we're going to use that whenever an equation already has an isolated variable. Elimination, we're going to use when the equations are already lined up for us. And graphing, remember on your EOC and on our NC check-ins, sometimes you will have problems where you are not allowed to use a calculator. That's why it's so important to learn the substitution and elimination methods. But if you have a calculator provided to you, then you can use the calculator. And we are going to practice this using Desmos.com. We did talk about Desmos and use it just a little bit last semester. This semester, we're really going to start using it a lot more. So let's come on down and start practice problem number 1. The sum of 2 numbers is 30, and their difference is 12. Find the 2 numbers. So I'm going to go ahead and do step 1 first, which is to define your 2 variables. So we're going to say x is going to equal the first number and y will equal the second number. Now we're ready to do step 2. Write the system of equations using the given information. So the sum of 2 numbers is 30. So if I take x plus y, it should equal 30, because sum, of course, means plus. Their difference of these same 2 numbers is 12. So it would be x minus y equals 12. So I've done step 2, which is to write the equations. Now step 3, we're going to solve this system. And we're going to do this one using the elimination method. Okay, and we're going to do that because these y variables are already nice and lined up, and they're also inverses of each other. Positive y and negative y together give me 0. And I now have 2x equals 42. I added 30 plus 12 because that's what their signs are. And now if I divide by 2, I get x equals 21. So now I know what x is. Let's go ahead and plug x into one of these 2 equations. Either one that you want to do is fine. I'll just pick the red equation. So 21 plus y equals 30. Subtract 21 from both sides. And now I know that y equals 9. Okay, now don't forget step number 4 is to answer the question that they're asking for. In this case, they're asking me to find both of the numbers. So I'm going to put my final answer as an ordered pair where the x value comes first. So 21, 9. Remember, that's an x first and a y second. Great job. What I want you to do is to try number 2 on your own. You try. All right, so pause the video and identify your two variables and then try to translate your two equations. All right, so I have identified x will be the first number and y will be the second number. And then I have translated the information to write myself a system of two equations. Hopefully you were able to get these same two equations. If not, if you're having trouble with the translating, please refer to your translation notes that you received last semester. And there was also some more translation notes that we touched on earlier this semester. All right. Also, you can call me over and I'll help you out however I can. Now we're ready to solve this system and to answer it. So I'd like for you to pause the video again and solve this problem and then give me the answer that you receive. All right, welcome back. So we solved this system of equations using the elimination method. Again, because I had a plus y and a minus y, so when you put those together, they're already set up to be eliminated. Then I had to solve that system and I found out that x equals 13. So I plugged that 13 into the red equation, and then 13 plus y equals 24. I just had to subtract the 13. And then I took my x variable and I put it in here first. My y variable was second. Great job. Let's go take a look at number 3. The difference between two numbers is 9. The first number plus the second number is 27. Find the two numbers. So the two things that I do not know is these two numbers. All right. I always identify which is which because if they ask me to find the second number or the larger of the two numbers or whatever, then I can just quickly refer back to what is x representing and what is y representing. Okay, so the difference between these two numbers is 9. So x minus y equals 9. Then the first number plus, so x plus twice the other number, that means 2 times the other number, is 27, so equals 27. So for this one, we can use elimination because they are already set up and lined up, or we could also use the substitution method. Even though one of these equations does not have an isolated variable, it will be very easy to create an isolated variable. If I just add y to both sides here, I now have x equals 9 plus y. And so I am going to plug that into here using the substitution method. 9 plus y, and then bring down the plus 2y equals 27. And then I'm going to continue solving. So y plus 2y is 3y. I need to subtract my constant term. And then 3y equals 18. And if I divide by 18, I find out that y equals 6. Okay? Now what I'm ready to do is to plug in this y variable into, let's do the red equation. I'm going to stick with the original of that one. So I have x minus y equals 9. And now I know that the y equals a 6. So let's add 6 to both sides. And x equals 15. So let's write the equation out to the side. X is 15, y is 6. And the method that I chose to use was, let me see, substitution, which I put in red up above. So substitution method. So those notes up at the top are suggestions, but you really can use whichever method that you would like, okay? I want you to try number 4. That'll be a you try. And you can use any method that you would like. I will let you know in advance that elimination method is probably going to be the easiest way. So I'd like for you to completely solve this entire problem from start to finish on your own. And if you get stuck anywhere along the way, just raise your hand and I can come help you. All right, welcome back. I have completely solved number 4 using the elimination method, and I got that x equals 14 and y equals 22, and they wanted me to find both the numbers. So I wrote them down out to the side in green. Let's take a look at number 5. The sum of two numbers is 20. So I know I'm going to have two numbers. So x will be the first number, y will be the second number. If I add them together, I get 20. X plus y equals 20. And then the difference between the first 3 times, the difference between 3 times the first number is x, so the difference between 3 times the first number and twice the second number is 40. Find the two numbers. So for a problem like this, I do want to review with you, how would we make these be a good candidate for elimination? So we're going to do elimination again. So in order to make this a good candidate for elimination, I need to choose a variable, either the x variable or the y variable. And I need the coefficients in front of them to be the same number value except opposite signs. And I can see already that the y's are already opposite signs and they just need the same number. Okay. I could also change the x's, but they have the same signs and they're already not the same number. So I'd have to think about two things for the x's. The y's, I only have to change one thing. So what I'm going to do is I'm going to multiply this entire equation by 2. So 2x plus 2y equal to 40. So now I'm set up to do elimination. So let's do that. So I made my 2y and my negative 2y be able to eliminate. Now let's put together the x's. A positive 2x and a positive 3x gives me a 5x. And then a positive 40 and a positive 40 is 80. Now let's divide by 5 on both sides to get that x by itself. And 80 divided by 5 is 16. So remember what I do now. I'm going to pick an original equation. So let's do the red one. The x plus y originally equaled 20. If I put a 16 in there instead for the x, Okay, so now I can see that I would just subtract this 16 and y equals 4. So now I have my final answer is 16, comma 4. Great job. I would like for you to, well, no, let's do number 6 together. Okay. The sum of two numbers is 25. So I know I've got a 1 and a 2. So if I add those numbers together, I get 25. X plus y equals 25. And then it says one number is, that means equals. So x equals 2 times or twice the second number plus 7. Okay, so I've translated that whole sentence. And they want me to find what are the two numbers. Well, this problem, how it's written, is already set up for the substitution method. So I'm going to do the substitution method because this x here is already by itself. So what I'm going to do is I'm going to take what that x equals and I'm going to plug it into that equation right there. So I have now 2y plus 7 plus y equals 25. And now I'm ready to solve this equation for the y variable. 2 and 1 is 3y. Let's subtract the 7 from both sides. And 21 minus 7 is, 25 minus 7 is 18. And 18 divided by 3 is 6. Great, so I've got my y variable this time. So when I write my equation, it's going to go in the back. Okay, now I'm ready to plug in that y equals 6 into one of the original equations. So let's use the blue equation that said x equals 2 times y, because now I know that the y is 6. So 2 times 6 is 12. 12 plus 7 is 19. So my x variable equals 19. So that's going to go in the front of my ordered pair. And just a reminder, what does my solution represent? It represents, if I were to graph these, the one particular location on the coordinate plane where these two lines cross over each other. Okay, if I were to look at it physically. All right, let's go over and do the right side of our paper now. And I just want to make a note that these equations that we're about to start looking at are going to be standard form. Okay, standard form equations are even easier to translate. So number 7 says the cost of 3 boxes of envelopes. So, okay, I have something here. I have x is going to equal envelopes. Okay, and then 4 boxes of notebook paper. So y is going to be paper. All right, envelopes and paper. And if you add those together, the total cost is going to be $13.25. So let's write that. 3 boxes of envelopes and 4 boxes of notebook paper is $13.25. Okay, now 2 boxes of envelopes, so this is a different sentence. 2 boxes of envelopes, so 2x, and 6 boxes of notebook paper cost a total of $17. Okay, so they want to know what is the cost of each, the envelopes and the paper. So what I would like to do is I want to use Desmos to show you how we can graph this. So I have identified my two variables, which is step number 1, and I translated the sentences and I wrote a system of equations. That was step number 2. Step number 3 is solving the system. So we've done a lot of practice with elimination and substitution methods. Now what I want us to practice is the graphing method, and we are going to use Desmos.com to graph. So let's go ahead and open up Desmos.com. And what we're going to do is on the left-hand side here, we're going to type in our red equation. 3x plus 4y equals 13.25. And so it graphed that red line for us, okay? And you can see any point on this line that you want to see. All you have to do is click and hold, okay? Now let's type in our blue equation. So if there's this teeny faded little number 2 here, that doesn't become a box unless you need it to. So as soon as I click on it, now it's a box, and I can type in the second equation. So 2x plus 6y equals 17. So graphically, you can see that where these two lines intersect is right here at 1.15 and 2.45. And that's how we can do this graphing method. Now, what would have happened if they actually crossed somewhere way outside of my graph? So I don't know, let me change this to something crazy like 200. And now you can see that the blue line has totally disappeared. If you zoom out, you can either use this button or you can use your pad, your touch pad on your computer, and you can zoom in and out. And then you would be able to see where they intersect, okay? So I'm going to go ahead and fix this equation back so I can remember what my solution was. So 17. Now I'm zooming way back in, and I can see that they intersect right there. So now let's go back to our paper and write down our solution. We just have to remember these two numbers. So the x value is 1.15. So that's why it was important for me to identify that x equals envelopes. Envelopes are 1.15 or $1.15 per box. And then paper was $2.45. So that was my solution. If you wanted to write it as an ordered pair on your paper, you can, 1.15, 2.45. And they wanted us to find the cost of each, so we did that. Let's do number 8. So I do need for you to go ahead and make sure that you have Desmos calculator open on your computer so that you can just click back and forth on the tabs. So Desmos.com, and then just click Start Graphing, and that should bring you right there. So let's try to translate this, okay, and identify what our two things are. So the cost of 12 oranges and 7 apples is $5.36. So I have oranges and I have apples. Okay, so now I'm ready to translate that very first sentence. So 12 oranges and 7 apples is $5.36. My next sentence reads, 8 oranges and 5 apples cost me $3.68. Find the cost of each. All right, so the cost of each, we are going to go to our Desmos calculator again. So open your internet browser. To clear everything out that's already here, you can just click the X's and it'll start you over. So my first equation was 12x plus 7y equaled 5.36. Click down to my second equation, 8x plus 5y equaled $3.68. So 3.68. Okay, so I'm going to zoom in. These lines they are intersecting, but I can't quite tell where. So what you're going to want to do is put your mouse on top of one of the two lines. And what they show you are the x-intercepts and the y-intercepts of that line that's selected. And then in the middle, they show you where they cross over one another. That's the point of intersection. So apples was X. Nope, apples was Y. So apples cost 32 cents and oranges cost 26 cents. So let us go back and write down our answer on our notes, okay? And what we're going to do, what I'm going to end up doing for these problems is putting the calculator steps that we do in the Desmos calculator for how we solve them. Okay, but I did find out that oranges are 0.26 cents and apples were 32 cents. Alrighty, so that's my solution. I want you to pause the video and I want you to do numbers 9, 10, and 11 on your own using the Desmos calculator and get some practice in with that. But remember, you still have to do steps 1, define the variables. Step 2, write the system of equations. Step 3 here would be your Desmos calculator. And step 4 is going to be to answer the question that they're asking. And be certain that everything that's here is written on your paper. And if you even want to just write a note for yourself, we did this at Desmos.com. Desmos.com, so that when I look at your paper, it doesn't just look like you copied what I had written, right? Or if you're trying to go back into your notes and to see how you solved this, it's good to know how you did it because you might not remember. So go ahead and pause this and then come back after you've completed number 9 just to check that you did it correctly, okay? All right, welcome back. This was my answer for number 9. And out to the side, I wrote down the steps that we do in the Desmos calculator. So step 1 is just type in both of the equations. Step 2 is to select one of the equations. Step 3 you may or may not need to do. It's a zoom in or out as needed. And my board kind of ran out of space there. And then step 4 says find the location of intersection. Okay, so that's how I do all the steps in my Desmos calculator. Now that we've done number 9, if you've gotten it correct, that's fantastic. So that means that you now know what you're doing for the identifying my 2 items, for translating, for using the Desmos calculator, and for understanding which variable of the ordered pair relates to which item. Okay, I'd like for you now to complete both numbers 10 and 11. Be sure to identify, translate, and explain your solution. Okay? All right, so go ahead and pause this video while you do that. I'm sure that you were able to do number 10 with no problem at all, but the translating part on number 11 was a little bit tricky, so I just wanted to talk about it. Notice that everything I have underlined in red deals with cost. The cost of the small lawnmower, the cost of the large lawnmower. And even though this is in a different sentence, they were telling me the total sales in a given year was that cost. So everything relating to money was in my very first equation. And then the second equation was the total number of lawnmowers sold was 30. So just how many small ones, how many big ones, and then the total equaled 30. All right. So now we're ready to go type this into Desmos calculator. And I have to tell you that with a problem like this, with how large these numbers are, I'm really glad that we have the Desmos calculator to fall back on. Okay. So let's just cancel out both of these equations and type this in. 249.99x plus 329.99y equals 8,379.70. So that's one equation. Don't freak out that you don't see it in this window. I'm going to have to zoom way, 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 way out to see my line. And there it is. All right. Now let's type in the second equation. X plus y equals 30. And I can see right there where they intersect. There were 19 small lawnmowers sold because that was X, and 11 large ones sold. So that was the Y variable. So let's go back to our notes and make sure that we put that on here. So 19, 11. This was 19 small and 11 large. Great job. Now we're ready to flip our paper over and let me take a quick look. I think that I'm going to have you continue to use Desmos calculator to really, really practice a few more of these. So 12 through 15, and then we are going to stop and we're going to do 16, 17, and 18. All right? All right, welcome back. I have done all of these in the Desmos calculator. So I've translated the equations, I've written the final answer. It doesn't look like there's a whole lot of work done here, but remember, identifying what X and Y equal in writing down both of your translated equations is part of the work. We actually found the solution in the Desmos calculator, and I wrote the solution here. But you do have to know that X is 76, so there were 76 balls that were purchased, okay? Or baseballs, whichever one you wrote down. So go through here, check your answers for these first 4 problems that you've done on your own or with a partner, okay? And then we're about to do number 16 together, and then I'm going to jot down a little note here for number 17 and 18, and you and your partner are going to spend the remainder of the time that you need in class to complete 17 through 20 on your own, okay? So let's do 16. A collection of dimes and nickels is worth $3.30. So I'm actually going to scroll down. All right. And these are going to be my notes for this. I did mention this last semester, but we do need to point it out again, that you are expected to know the value of a penny, a nickel, a dime, and a quarter. Okay, a penny is 0.01 as a decimal, a nickel is 0.05, a dime is 0.10, or you could just say 0.1, and a quarter is 0.25. That is the information that they failed to point out to you. Okay, so a dime is 0.10, a nickel is 0.05. So the two things that I have are dimes and nickels. Okay. And really it's representing how many I have. I know their value, but now I need to figure out how many, right? Of each kind. So now we are ready to do our translating. So a collection of dimes and nickels is worth $3.30. So we're talking about their value. So dimes and nickels, and their value is $3.30. If there are 42 coins in all, so 42 total coins, how many of each kind of coin are there? So what do I need to write down for my second equation? Well, I need to know and account for the fact that I only have dimes and nickels. So I have that many dimes and I have that many nickels, and when I add them together, it will equal 42 total coins. And so now that I have gotten this completed, I can go to the Desmos calculator and I can just type this in there. And I can type them in any order that I want to. So x plus y equals 42, and then 0.1x plus 0.05y equals 3.3. And so where they cross over is right here at 24, 18. So 24, 18. Let's go write our answer down here. 24, 18. So X is dimes, nickels is the Y variable, which is 18 here. Okay, so that's your answer as an ordered pair, and that is how many dimes, how many nickels, just so that we know which one it represents. So let's go take a look at 17 and 18. Okay, and all I'm going to do is fill in what we need to know. So we need to know, again, the value of a nickel is 5 cents. The value of a quarter is 0.25, 25 cents. Okay, nickels, again, 0.05, dimes, 0.10. And that is all that I'm going to give you for these last four. I will be grading this as a part of your notebook check at the end of the quarter. So be certain that you've gotten these filled in. Please do not just blindly copy them from anywhere. This is really important practice for you. And as you're working through this practice, you can work with someone and you can ask me for help. Okay. 17 through 20. But it is important that we are practicing. Mostly the practice today is the translating and using the Desmos calculator. Okay? All right. Until next time.